Hey everybody, it's Mr. Sheeline here. This is just a quick little walkthrough and more or less just initial data collection, just in case that you missed out on this portion of the lab, in case that you are at home and are going to come in on the next following in class day to get going on this. It's just a quick little video to go over some of the questions and really what to be doing. So just real quick to go over what this lab is. The purpose of this lab is to help you guys develop an understanding of stoichiometry in the real world and where we could actually apply it and see differences where we do apply it and where we don't apply it. Okay, so background information, just real quick, really quick little neat tidbit of info, and it's specifically about the creation of soft drinks and why they're called soft drinks. So a guy by the name of Joseph Priestley is made the first ever man-made non-alcoholic carbonated beverage all the way back in 1767. Now this is super important because specifically if you wanted a carbonated drink like a cider or something, typically it had to be fermented. And in the fermentation process, you made alcohol. And so, you had the choice. Do I want to drink tea, or do I want to drink something a little sweeter, something that is a little bit more palatable, but has some alcohol in it, which obviously has some, different kinds of effects on different kinds of people. Okay, because they couldn't just go to a tap and get the tap because the water just wasn't that great. Especially if you were in late 1700 New England, pretty much all the water that they were yanking out of the ground was rancid, and they had to boil it all the time. And there was very little filtration process. It was not the same standards that we have today. So anyway, so he used chalk and calcium carbonate and sulfuric acid to produce carbon dioxide, which then bubbled and infused into water. And then, and like I said, carbonated beverages, they weren't new, but Priestley's process was. Before this, like I mentioned also, is that they were produced by fermentation, which again, ultimately produces alcohol. Okay, now today we're going to be practicing that in our own little way, only we're not going to be using calcium carbonate, we're not going to be using sulfuric acid here. We're going to use something a little bit more, a little less volatile and a little less corrosive. We're going to be using some citric acid, some canning citric acid to basically do the same thing. So here are all of our materials that we're going to be using. So we've got Kool-Aid, citric acid, baking soda, plastic spoons, all this stuff. We can read this out on your own, and we'll see where we're going to use it here. But just to keep something in mind, that while we're working on this in class, make sure we do follow these safety precautions. We're going to be wearing goggles because citric acid is a nasty little thing to get in your eye. You do not want that in your eye, so we're going to be wearing goggles just in the case that we spill a little bit. Or get it on our hands, more on our hands than we think, and then rub our eyes, because that will be a very bad time. And then also sodium bicarbonate, just to be clear here and be safe with it. And really, when we're completing the lab, you're not going to get a whole lot of it, but just be aware that sodium bicarbonate is slightly toxic if you ingest a whole bunch of it. Just to be aware of that. And then also while we're working in the lab, obviously masks for the most part have to stay on. About the only time you can really take them off is when we're sampling the material in the lab here. Okay, and one of the few labs where we get to actually taste the material that we're testing. Okay, so let's take a look at these pre-lab questions. So in this pre-lab questioning, super duper simple. All I really want to go over with you is calculating the molar mass of both the citric acid and also the baking soda, okay? Because we're going to be using this info quite a bit throughout this lab, okay? All right, so let's just real quick get the calculation for citric acid here. We're going to finding again the molar mass of citric acid. So it's going to be, let's see, we've got hydrogen, we've got carbon, and we've got oxygen. We're finding that molar mass. Well, we've got 8, count them 8. We've got 3 here, 5 there, so 8 atoms of hydrogen. Each of them has an atomic mass of 1.0. Carbon just has 6. That has an atomic mass of 12. Oxygen, there are 7 of them, 7 atoms, and its atomic mass is 16.0. Okay, so this is going to be 8.0 This will be 72.0, and then this bad boy is going to be 112.0 grams, AMUs, all the way down. Add them all together, and we'll have 192 grams per mole H3C6H5O7. Okay, we got the molar mass of our citric acid. Okay, here's our molar mass of the citric acid. Okay, so we've got that. Now let's get the baking soda. Baking soda is going to be sodium, hydrogen, carbon, and oxygen. Okay, looks like there's one of this guy, one of this guy, one of this guy, and then 3 of him. Sodium, oops, not 2.3, 23.0, sorry. Sodium has an atomic mass of 23.0. Hydrogen, 1.0. Carbon, 12.0. Oxygen, 16.0. So this is all going to transform into 23.0, 1.0, 12.0, and then it's going to also be 48.0. And we add all that up, we're going to get 84.0 grams per mole for our sodium bicarbonate. And then we've got that bad boy right there. Now, before we go to this next one to see what we're doing with that, we've got to log this into our data table. So let's flip her over and see that we've got some data tables here. Okay, we have the quantitative and then the qualitative data tables here. So in the quantitative is where we're going to be filling out this information. So the molar mass of our citric acid, well, we just found that. Molar mass of citric acid is 192 grams per mole. And then our baking soda is what we just figured, which is 84.0 grams per mole. Okay. And while we're here, let's now fill out the rest of this quantitative data table because we've got everything that we need for these two. We don't have this yet. That's going to be something that will be later on in part 3. But moles of the balanced equation here, we're going to look at the balanced equation. And it's just asking for the molar mass. Okay, or sorry, the molar ratio. So here is our citric acid. Here is going to be our baking soda. And it looks like we've got 1 citric acid, 1 mole of citric acid to every 3 moles of baking soda. So there's 1 mole of citric acid to 3 moles of baking soda. Okay. Again, we're going to wait for trial 4 here. And then lastly, to look on the front, just understand, here's our balanced equation, and continually come back to this so you can see what the balanced equation is. You're going to need it for a number of questions throughout this lab. So make sure we come back to this. And then this is just for some, little bits of like, okay, what is each thing? Well, again, here we've got citric acid. Here is our baking soda, our sodium bicarbonate. And then this stuff here, we don't need to really know what it is, but just to let you know what it is, it's sodium citrate. So here we've got sodium citrate, and then that's one of our products. Another product here is just water, and then another product here is going to be just carbon dioxide. Okay, so just in case you're wondering what each of these are, okay, this is what each of them represent. Especially this one was the unknown, and that's what that is, just sodium citrate. Okay, oops, yikes, ouch. Okay, so let's just kind of walk through. So here's what we're going to be doing, just as an overview. After we get all this information, after all of this information's been processed, now we finally get to go begin the lab. So you can go ahead and read out what each trial is going to be, what each trial you're going to complete here, and all the steps in each trial. Everything's been pre-measured for you, with the exception of trial 4, and we'll get to that in a second. But everything's been pre-measured for you. Basically, you just have to follow the directions that are provided. In each trial, you're making your observations down here. So notice, trial 1, here's trial 1, here's what's inside trial 1, and you're going to give me your observations. What does it look like? What does it smell like? What's its consistency? What does it have a different sheen? Like, is it cloudy? Is it clear? You're telling me, what it is that you see. Okay, so basically, what do you see and smell, and just observe. And then for the taste here, so clearly after you're tasting it, you're going to tell me what is it that you taste. Was it sweet? Was it sour? What was the flavor? You're going to tell me, was it watery? Was it, you're telling me what you thought the taste of it was. That's all you're putting there. And you're going to be doing that for each trial here. Okay. Now just notice though, trials 1, 2, and 3 are right here. And those are corresponding also right there. And then number 4 here is again going to be in part 3. Okay, so you finish part 1 while you're in the lab, and then part 2 is a little bit of calculation. So now that you've tested out the differences between the different ratios of Kool-Aid to citric acid to baking soda, now let's explore how well stoichiometry can help us with the flavor and consistency of our Kool-Aid. Now, hopefully, using Stoich, we can create a fizzy, good-tasting drink. Because, to be honest, maybe that the other drinks that you just tried weren't so great, and maybe, understanding a little bit of Stoich and calculating some things out, maybe we can make it an even better drink. So starting with 0.3 grams of citric acid, complete the following calculations. Show your work and record your results in the quantitative data table and keep your answers to 3 sig figs. Okay, so this right here is, let's see. I probably should have gotten rid of this. Ignore this line. Ignore this portion. We don't need to worry about that. But we do need to keep our answers to 3 sig figs. But we don't need to worry about that because we've already done that. This is already done. Okay, that's already done. Okay. So there's a specific amount of baking soda, reading here, that will react with 0.3 grams of citric acid. So let's use stoichiometry to see how many grams of baking soda is needed to react with 0.3 grams of citric acid. So this is what you will do on your own. You and your partner are going to say, well, we're starting with 0.3 grams of citric acid. We know that only so much citric acid is going to react with so much baking soda, okay? And one of them is going to run out first, but in this case, we want to know if we're adding this much in, according to the balanced equation, how much do we need of baking soda in order to use all of this up, and then also use up all of the baking soda that we're adding to the mixture as well. So you're just going to convert from mass of citric acid, so mass of A, and you're going to convert to mass of B. And B is just going to be baking soda. So that's what you'll do here. And then number 2 here, what you're going to do is that here's what we started with. You're just going to, whatever answer you get up here, you're just going to record it right here. Okay. Easy peasy like. So that's parts 1 and part 2, and that's what we're focusing on day 1. Okay. Day 2, while you're at home, and that's even, day 2 could be part of this as well. So arguably day 2, if you didn't complete everything in part 2 here, day 2, while you're at home, would be completing this little spot and even be answering some of the post-lab questions. Okay, but let's say we're now at day 3. We're back in class. We're in person. We're going to start part 3 here. Okay, so part 3, you can read these instructions. What you're going to do is you're going to be mixing this 0.3 grams of citric acid, and you're also going to be mixing that, and you're also going to be measuring out whatever amount of baking soda that you calculated here. You're going to measure that out, and you're going to mix it with a new batch of Kool-Aid. So you're going to mix that new batch, or you're going to mix that with your batch of Kool-Aid down here, and then you are going to taste it. And then you're going to go back to your qualitative data here. You're going to pop in, what do you see? What kind of observations did you make? Was it cloudy? Was it clear? What color was it? What was the smell? All that stuff. And then you're going to taste it, and then you're going to tell me how it tasted. Okay, be super specific, did it fizz like we expected to? Did it not fizz? Was it super flat? Did it change the flavor between any of these 3? Okay, you're telling me exactly what you taste in here, but it's going to be part of trial 4. Okay, And then that's going to be the end of, the fun portion of the lab, as some of you may see it. And then we're going to move on to the post-lab. And the post-lab here is just answering these questions. So the first two are completely subjective. How did your drink turn out in trial 4? So tell me, using your observations and what, the notes that you took while you tasted it, how was it? And then number 2, maybe talk about what you could have done in order to make it taste better. So, just as an idea, would you add more citric acid to it? Would you add less baking soda? Or vice versa? Would you add more Kool-Aid? Would you change the flavor of the Kool-Aid that you had? What would you do to modify the recipe that we just put together? And then here, number 3, if you had 10 grams of citric acid, how many moles of citric acid do you have? Here is just grams to moles of substance A, just simple conversion. And really all this is, number 3 will lead you to number 4, okay? So we're just starting here, 10 grams of citric acid to moles of citric acid. And then number 4 is just asking, well, using your answer from here, what's the number of mole, or you're then going to convert moles of citric acid to moles of carbon dioxide, okay, one of the products. And then you're going to restart over here. So if you got 10 grams of baking soda, okay, you're going to go from 10 grams of baking soda to moles of baking soda. And the same thing here for number 6. How many moles of carbon dioxide were produced, or how many moles of carbon dioxide would be produced using the number of moles that we figured up here. Okay. So recap real quick. So here, grams of citric acid to moles of citric acid that you got up here to moles of carbon dioxide. Here, it's moles of baking soda. Oh my goodness. Mass of baking soda here to moles of baking soda, and then moles of baking soda that we found from up here to moles of carbon dioxide. And then the last final question here for number 7, referring to the answer you found here and what you found here, which reactant is going to give you less baking soda? Make sure you see it's less baking soda. Not more, less. Who produces the least amount of baking soda? Okay. So, and that is the lab, guys. So if you have any questions for me, if you were not present during this lab, make sure you get a hold of me so I can address any of the questions that you have. And then if you weren't present, that we can schedule a time to when you can come back and complete this lab, after school, before school, on a Friday, anything like that. So that's the video. If you still have questions, get a hold of me. But if not, I'll see you guys in the next one.